We started recording. So what I'm going to do is to present the workshop a little bit, the symposium and the lab. But this is the first public event of the Intelligent Instruments Lab, and we are a research lab that is funded by the European Research Council, and we have 5 years ahead of us working in the Iceland Institute of the Arts, University of the Arts, and we're looking into how artificial intelligence can be embedded into physical instruments, musical instruments. But we're also looking at musical instruments as scientific instruments, as instruments of culture, extensions of our body. So we're really in this situation here, you know, we're like the thinker looking into technology, looking at ourselves using technology, looking at ourselves designing technology, and interacting with people who use the technology, our technologies or other technologies, in how they respond to it, and trying to detect what kind of language comes up, how people feel about things, how people think about the kind of extra agency that you get in your instruments when you add artificial intelligence in them. So this is a humanities approach to technology, but it's also a technical approach, and it's also an art approach. It's artistic research. We're interested in working with people, so we work with designers and people, musicians, and people who are performing with instruments, audience members. We're really interested in kind of engaging with these people in order to get ahead with our work, because we don't believe in the solipsistic kind of approach where you sit alone somewhere and suddenly bring something to the world that you've been working on for months or years, and it doesn't work because you've been in a bubble designing it. So we have a team of people, and this team is a team of people who is quite experienced in engaging with with users, with musicians, instrument designers, engineering designers, computer scientists, and so on. And we're a team of people who really would like to work with people, with users. And we have set up a lab on the 4th floor in Þverholt in the Iceland University of the Arts, and people are welcome to come and visit us there. This is a recent picture of our lab, with furniture that can be turned into instruments, modular kind of systems, and we will be working there for the next 5 years, depending on how quickly we move into the new university in Tollhúsið. Anyways, this is how we see our lab. We want to see our lab as an a laboratory of ideas, of studying, of doing science with sound, of doing practice, of having items around us that can be modular and plugged together in an easy way, such that ideas can be quickly investigated and tried out. People can come into our lab and put things together quickly in a modular way and try out ideas. And it's really through this kind of ease of access and ease of setting up the experiments that I think we can develop things quickly. So this is how we're going to work. We have 5 years. We have 3 work packages or themes. One is about the self, where we study the instrument and our relationship with the instrument. That is a kind of phenomenological approach. So you're looking into how you feel with the instrument, what kind of ideas pop up, and so on. So it's introspective. You're trying to figure out what the instrument does and how you change yourself or your music, your behavior playing it. The next work package starting next autumn is called Others, or maybe one where we have a sociological approach, where we consider the sociology of humans and non-humans, of non-human agents which are in our instruments, and we're able to kind of play together and work together, and that's really where we take our instruments onto the musical stage or the studio, and we try them out, and we collaborate. So that work package is less about the design of the instrument, but more of the use, how we use these instruments together. The third work package is then about knowledge, how we can produce scientific knowledge with these instruments. So we're looking at musical instruments here as scientific instruments. So this is a work package of epistemology. We're thinking about how instruments with machine learning might be able to explore data, big data, through sonification, for example, and contribute really to the science of auditory display through musical instruments, through embodied instruments, because a lot of sonification has just been offline, kind of press a button and listen to the data, but we want to engage with the data through an embodied way. So these are the research themes of our lab, and what we're really doing. I wanted to say we have some openings, PhD 2, PhD 3 coming up in the next 2 years. We have some MA students that could be working with us, and visiting artists and researchers. And we're really working with this approach of having an open lab. I have some pictures here of our open lab where we kind of get people to come and show their instruments, play with us, talk, have ideas, because we believe it's really through the open dialogue that we are able to get some interesting ideas. So here we are in the Moving Strings Symposium, and this is a symposium that focuses on strings. We're not thinking about other areas of our work, but on ideas of how we can move strings differently. We have some presentations about feedback instruments, and then we have the magnetic resonator piano that we heard about earlier. So that's really what the theme is about now. It's the theme of moving strings, of how we extend or augment our instruments with technologies to kind of rethink our string instruments. So this is the program. I'm finishing my introduction now. We have Andrew McPherson then presenting. Chris Kiefer unfortunately can't be with us today, but then we have Adam, we have Tabita, and then Halldór and Guðmundur Steinn, Davíð, Brynjar, Franzson, and Victor Shepardson. Then we have a break and a panel at 4:25. So I think I'm going to end now, and I'm very excited to hear the presentations with my colleagues here. If there are any questions to me or for me, you can bring them up now. And of course, you can learn more about our lab here on these links. I'm going to stop sharing and hand over to Andrew.
Right. Thank you, Thor. So it's occurred to me that probably a good number of you here heard my talk this morning. So and on the one hand, I don't have a lot sort of new to present about the instrument compared to what you heard. On the other hand, I don't want to just kind of bore you with the same things over and over again. So I think what I'm going to do is I'm going to play the video just to show you what the instrument is about if you haven't seen it or haven't been at one of the workshops. And then I'm going to go back to the part toward the end of the talk talking about the kind of evolution of the instrument and the aspect of community building, because I think that is an interesting sort of seed for discussion later on. So I'll share my screen now and just present just a little bit. Sharing the sound. There we are. Yeah, so this is, oops, this is not the part I wanted to present. There we are. So this is the magnetic resonator piano. It's an electromagnetically actuated acoustic piano. There's electromagnets that are placed inside the instrument. They don't touch the strings, but they hang just over the strings such that when the magnets are activated, they can make the strings vibrate. And the crucial part about this is that the process is continuous. You can change the frequency, amplitude, timbre of string vibrations just according to what signals you put into the magnets. The whole thing is played from the piano keyboard using a scanner that produces not MIDI data, not note on, note off, but actually continuous key angle updated several hundred times per second. And then there's a whole layer of gesture sound mapping between the two of them, which I talked about more this morning. I'll play this video again for those of you who've seen it this morning, just to give you an idea of what this is about. Right, so hopefully that gives you an idea of what it is. Now, that video is from 2011, so that was 10 years ago now, and this instrument has been kind of continuing since that time, almost despite my best efforts in some ways. It kind of keeps having a life of its own. Now, the reason that I built the instrument, as I talked about this morning, actually was maybe not so much a technical motivation, but a very personal musical one, which is that I found it very terrifying as a composer to write pieces for solo piano. I was in a composition PhD program, and I'm a viola player primarily, and I think that really influences a lot of my thinking on this instrument and others. But as a composer, I found it very difficult to write piano music for all sorts of reasons, both technical, what fits under the hands, and musical, just the kind of weight of repertoire. So this instrument was sort of my personal creative prompt to be able to write some piano music that maybe by slightly changing what the piano was about, I was able to get my own creative inlet into composing for it. But what happened after that was maybe somewhat unexpected, but really quite exciting, which is that I started working with other composers, first around the Philadelphia area where I was based, and then later in London after I moved there at the end of 2011. And at this point, there is a repertoire of over 30 pieces for the instrument, a lot of notated classical works, but also really across genres, jazz, rock, operas, film scores, what have you, and then of course a lot of improvised work as well with the instrument. I talked this morning a bit about notation systems because this is a thing that oftentimes comes up. How do you notate for a new instrument? And I think the best thing to do maybe is to step back and let the notation emerge rather than to try to be prescriptive about it. So I didn't necessarily tell people you should notate as I notate, because and here I quote Thor as I did this morning, that notational systems are basically a way of transcribing sound. And this is fraught with difficulties, for such an endeavor is always a process of selective abstraction and classification. The transcribers will have to fit what they hear into the symbolic language available, which most likely is also the language in which they think, so it might be even harder for them to hear certain specifics in the music that are valued by them. And so Thor here is talking about especially Western musicologists notating music from other cultures. But I think this also can apply for notating music for new instruments, where they potentially introduce new elements that can become salient. So I tried to leave this open, basically. And I showed, as I showed this morning, a variety of different projects that have happened with the instrument. This was more of an installation exhibition situation. Here's a rock album by the band These New Puritans, another composer collective with 4 new commissions in Los Angeles, an opera with Maria Caliampa in Rome, a piece by Jonathan Pitkin at the Royal College of Music, and an extended collaboration with Xenia Pestova-Bennett, which is still ongoing, where she has written a piece called Glowing Radioactive Elements, and then another one with the Ligeti String Quartet called Atomic Legacies. And these are semi-notated, semi-improvised pieces that really engage with a lot of the details of the instrument. And of course, there's lots more that I haven't mentioned, and I don't mean to in any way minimize the other amazing pieces that have been written for this instrument. There's a list on my research lab website, instrumentslab.org, and videos and audio of a lot of them. Here's a film score that was incorporated the instrument, that came out in 2019. And so then I guess what that brings me to is that the instrument as it exists now is not the instrument that it was in 2009, although certain aspects of its identity remain the same. The first version of it was built very cheaply because I was a poor PhD student at the time and involved a lot of hand wound stuff and things that were absolutely the cheapest things I could get my hands on. And I learned a lot from this. And so generation 2, which was made in 2011, really changed quite a number of things. Both in terms of professionalizing the mechanical and the electronic setup. Again, all of this really custom designed, but using higher spec parts. And then the biggest change to the identity of the instrument was to move from a MIDI-based control to the continuous key angle control, which I developed in 2010. And from that point to the present day, there are now 4 complete MRP kits in existence. The newest of them lives at the Icelandic University of the Arts in the Intelligent Instruments Lab that was set up just this Monday. There's one with me in London, of course. There's one in Brussels with a group called Echo Collective, and there's one in Philadelphia at Drexel University, where I was for my postdoc prior to going to Queen Mary. And then there's a handful of bits and pieces of it that are elsewhere. Some people have magnets and amplifier kits that I've built. Some people have just the keyboard scanner, using it as a MIDI controller, that sort of thing. And this most recent process has been really just around the pragmatics of kind of getting myself out of the way of the instrument so that other people can set it up and use it, and it kind of minimizes the sort of hidden, I guess maybe the tacit knowledge that I bring about how to set it up and debug it, and make this more transparent to other people. So I think maybe I'll just stop there, and we can discuss perhaps in the panel later on these questions around community building, around the formation of identities of instruments, and potentially notation for instruments. So thank you very much.
All right, thank you very much, Andrew, and thanks also for your talk this morning. So we have a couple of minutes in between talks just to take any immediate questions, and then, as Andrew said, there'll also be time for questions later on during the panel. So if you have a question, please feel free to post it in the chat there. And Andrew, I think Leon West has given you a question there, if you're able to see that.
Very good question too. So regarding the Moog piano bar, has anyone ever proposed using an alternate MIDI controller, as in a standard MIDI keyboard? So is the question, can you put a scanner like the one I use onto a different keyboard, or is the question, can you control something can you control this kind of effect from a MIDI keyboard? Sorry, I suppose it's not. I suppose you can't really turn your own on. Yeah. could you control the MRP from a MIDI keyboard? Yes, you can. And in fact, my first piece for the instrument, Secrets of Anakithra, which I wrote in 2009, was done entirely from MIDI. Now, I mean, you know, the trade-off though is that you just don't get the degree of detail that you do from a continuous scanner, because you can turn the magnets on and off, and you have a velocity number that you could in principle do something with. But I think for me, so much of the identity of the MRP as an instrument is in the subtlety of the ability to shape the sounds as they go along, rather than than just having something that's a kind of on-off organ-like effect. And so you could potentially have a MIDI controller with aftertouch that could do that kind of thing. But even so, I mean, the real subtlety for me is not actually what happens when you get to the bottom of the key. The real subtlety is what happens in the first 1 millimeter of key throw, actually. And if you look at some of the videos of the instrument, especially Xenia's performances, you'll see that there's a whole kind of a miniature, beautiful kind of world that somehow exists within a millimeter of the start of the key. And that's part of the identity of this instrument. Now, you can electromagnetically actuate other instruments, and they are their own artistic devices. So, in that sense, yeah, absolutely use MIDI. But, in terms of what I consider the MRP as an instrument, a lot of it's in the continuity of the control. For what it's worth, for anyone who's interested, I am making a new keyboard scanner which replaces the Moog piano bar, where everything is engineered for continuous position from the ground up. And this is designed to be a sort of modular thing, so it could potentially go on keyboards other than the acoustic piano. And if this is the kind of thing that you are interested in, then drop me a line. I'll put my email address in the chat, and would be happy to follow up.
Awesome. Any more questions for Andrew before we move on to Adam Pultz? All right, thanks again, Andrew. We'll see you again in the panel. And welcoming Adam to present next.
Thank you. I'll just share. Do you see my full screen now, or do you see the back end?
We're seeing the back end, like the slide previews and so on.
Okay, sure. Wait. Okay. Same thing.
Yep, that's the same again.
Okay, maybe I'll run it like this then.
You could try at the bottom there, next to the zoom bar. Isn't there like a button next to the minus on the zoom bar at the bottom of your screen there? If you take your cursor down, isn't that the one where you, yeah? Oh,
here?
No, on the right, next to the zoom. Not this one, not that one. Just that one. Yeah. No, if you go, you have to go down. You were there earlier.
Oh, I see. I think I see what you mean.
Next to the zoom bar.
Wait, here?
No.
Nah.
Oh.
Wait, like.
Not that one, but the one on the other side of the slider. On the other side of the slider.
It's right next to the minus symbol, where you can press like minus and plus.
Oh.
Yeah.
No, but the button next to the minus.
This one?
Yeah, I think this one. I think it's this one.
Does this work?
Yeah.
Okay, great. Thank you. Whoops. Okay, so I'll start. So my name's Adam Pultz. I'm a double bass player doing a PhD at Sonic Arts Research Centre in Belfast at Queen's University, and I'm here to talk about the feedback actuated augmented bass, or the FAB, which Halldór and I developed in the spring and summer of 2019, 2.5 years ago. And we, Halldór suggested that we apply the principle of his halldorophone to a double bass. It had, so the halldorophone works with as a feedback loop with the electromagnetic pickups, picking up the signals from the strings and amplifying them through a speaker built into the back of the instrument. It has also been applied to cellos by Chris Kiefer and Alice Eldridge, but this was sort of the first time we did it. It was done with a double bass, and so wait, for some reason it's not showing my images. Just give me a second. That's curious. I just need to. Oh, why does this not work? Please give me 1 minute to get something, a hard drive. It'll take 2 seconds.
No worries. Okay, so maybe while Adam's just figuring out his technicals, Adam, would you like it if we switch to Tabita while you're figuring things out?
Yeah, let's do that. That's a good idea. Thank you.
All right, no worries. See you in a sec.
Yeah.
Tabita, are you all right to take over and present next?
Yeah, sure. I can see if my presentation works.
Let's give it a quick test.
So if I go on share screen. And I select this. Can you see my presentation?
I can see Keynote, and then did you want to press play there as well? Yep, looks good.
Yes. So I didn't put a slide for an introductory part, but I guess you can see my face as well in the Zoom. So my name is Tabita Cargnel, and I'm coming from the background of architecture. So I studied my bachelor in architecture, and my master's was design for performance, where I developed this Venus Myers instrument. And yeah, as a child, I learned to play the piano and the violin. And yeah, as a researcher or instrument maker, I'm coming more from the intuitive side, and I do more like abstract painting, and generally I really like making things. And my heart within this project lies where the music making is like playing together. So I made this Venus Myers instrument, which is supposed to be like a 360 degrees instrument, which is like symmetrically to all of its size. So there can be like 3 or 6 or 9 people playing it. And yes, so before I talk more about it, I wanted to show you this video. Can you see my Chrome, my browser? Can you see it?
We're just looking at Keynote right now.
Okay, so then I need to switch it. How do I get back to Zoom? Stop share, new share. So I'm just gonna switch it like this. Can you see the video now?
Yep, that looks great.
Also, shout if you can't hear the tone.
I think we're hearing it through your laptop microphone, but it's probably okay. Unless you want to try and quickly change it.
Yeah, I'm not sure how I could change it really.
It's okay. We'll post the video link in the chat as well, and then people
Exactly.
can
It's
hear
just on
it
YouTube.
properly.
You can find it if you put Venus Smiles and performance. Yes, so I think you can see a bunch of the interaction possibilities and you have an idea about how it sounds. I guess most of you might have seen the video before anyways. So I'll try to switch the screen share back to my keynote. Yes, and about this performance, these were like 3 musicians playing, which have seen the instrument only for the first time on that day. So this was like a pure improvisation, which we kind of made up on the day. So I'm sure you could also like compose something for it and get like other tones out of it if you wanted to. And yes, so how do I define the instrument? So Venus Smiles is a sound sculpture for communal performance. And the tubes, they're made out of copper. They're suspended in the air in this architectural system, which is called tensegrity system. And you can play it with your hands, with like plucking like a guitar. You can play it with a bow. You can sing to it, and it will amplify your voice. And the like instrument making idea is that every element which is built into the instrument is tuned to the main resonance mode of the bass or of like the longest tube. In this case, they're all the same length, but generally that is like all tuned to each other, so it's harmonically in itself. And yes, through the tensegrity system, it sounds very reverberary and immersive. And there's no mechanical or technical like extensions to it. Currently is purely analog, just working with the materials like a traditional instrument, for example, like the violin. Yes, and I chose that to be the case because I like the immediate feedback which you get through all the vibrations. And I think in all the new instrument designs which we do, we tend to forget that we're working with materials which have sonic qualities. So I wanted to focus my research only on the sonic qualities of materials and how to use that in an ideal way so the instrument amplifies itself. Where did my journey begin? As an inspiration, I had this short story, which I really like, which you can find in the internet if you want to have a fun read, which is by James Graham Ballard. And he writes about this, in the story, there's this instrument maker, Lorian Drexel, which is commissioned by a city. She's an artist to make a sound sculpture, and she makes this sculpture, which is made out of metal, which is a bit like a plant, and it's placed in the city. And first it begins to play like, it seems to be like a Aeolian wind harp, for these who know it. And it plays like sounds with the wind, which sound like Mozart, very sweet, like the early Mozart. And then with time, it stays there, but it begins to grow. like a plant, like a tree, and the sounds get more like louder and louder and more abstract, and at some point it's quite terrifying, and they decide that it's going to be too loud for the citizens, and they decide to cut it down and melt the metal, so it basically gets recycled, and as the metal becomes part of the cycle, like of the, it gets reused for building, like constructing buildings, and then it turns out that the whole world is gonna start to sing and to ring because the plant metal, which was sonically very, very ringing and loud, infected all the other metals, and all the houses are instruments. And it's a bit of a dystopian story where the ending is not good, but I quite like the idea of having like singing houses or like cities. So the system, the architectural system which I'm using is called a tensegrity system. And the word tensegrity is made of the words tension and integrity, which means that the system can only exist in its, if all the parts are there. In the picture which you see here in the background, there I put more strings in than you need to put, just so in case if one breaks, it's not gonna collapse. So it could be more simple than what you see here, but the idea of the tensegrity system is that through the integrity of all the parts and through the tension, like the wires on tension holding everything together, it is a spatial construction. And yes, the system is invented by Buckminster Fuller, and I'll talk later about it anyways. So here you can see some like very simple systems, like tensegrity systems, which are made of 3 struts. And the one I'm using is the one at the top right. And the earliest one was built in the early 90s, and it's called Needle Tower by Snelson, and he was a sculptor. And yeah, usually these tensegrity systems, they're just architectural systems, or they're mainly used in the field of arts, and I've put my focus into making them sound. And yeah, I'm sure you can just to pronounce it as well. So on the top right, I'm not sure if you can see my mouse cursor, probably not. On the top right of like all the small images is like the 3 strut structure which I'm using, and it's the same one in the big picture by Snelson. It's just like added endlessly on top of each other, and this is like part of the idea of the instrument making, that you can have like one small module of a tensegrity thing, and then you can just like add it endlessly, and you can also change the shape as you want and make like a spatial construct out of it in any direction. And yeah, the main architect, like who also did lots of research about it and evolved some sort of philosophy around the tensegrity systems, is called Buckminster Fuller. If you want to know more about this, I would like to recommend you this book, which is called Operating Manual for Spaceship Earth, where he starts with like storytelling to go more into the topic of sustainability, and like he wants to use the tensegrity system thinking to make the world a better place, to kind of like, he was kind of already thinking about climate crisis and all of these things in the early 90s. And from my point of view, why the tensegrity system is like, seems to be like a really good system, really sustainable system, is because you don't need very much material to make a very strong system. And then I guess you're not architecture students, but I still find it interesting. And then it's because it's made of the tension elements and not only compression elements. You're not like just stacking bricks on top of each other, but you have like something held up by tension. It's quite a flexible system, so it's also more flexible to react on forces coming from the outside, which are also very good from a sonic point of view, which I'll get back to later. Then tensegrity is a system which we find also in biology, like many very well working principles, and you could see the fascia as like the strings of the body and the bones as the rigid elements. And the tensegrity is now more used in biology to find out where like problems lie, and to like help especially like people with sports to exercise their body. And here are just some examples of how you can see your body as tensegrity systems. And you could even think like also thinking in different scales, you can find different sorts of tensegrity structures in nature and in the human body. For example, also if you go like deeper in with DNA, for example, like on a very molecular level, you can find it as well. And yes, what's interesting for me is tensegrity in sound. Like, why did I decide that this is going to be a really good system to make it sound? And as you can see in this photo, it's like nice to have something which is basically freely hanging and not attached to anything else. And here it's a tube being suspended by strings, and you can also see 2 tuning pegs. And what's nice about that is if you hang something made of metal, that you can have a bell sound at the same time as you can have like the bowing sound from a violin, because it's held by a string. And yes, here I've got a little video about, well, oh, it's a bit too short. I trimmed that one too short, but what this video was supposed to show is that the system is quite flexible. So you can, if you push it, it will move with you, and through the flexibility, maybe, I hope this one, I didn't cut it too short as well. And you can hear the flexibility also in the sound, resulting in some sort of vibrato. Okay, so and what's nice about the flexibility of the system is that then if you play a note, it's gonna ring for a longer time, because the materials, they're not stiff but flexible, so vibrations are more likely to last and amplify also each other. And here, this is one of the earliest tensegrity systems which I built, where the bell sound got lost because the connection points were not as evolved yet, but you can already hear the effects of the tensegrity system, of everything being like flexible. So what you can hear here is also that not only there's a very long reverb time, but also because everything is very resonant, you can hear lots of overtones, which I quite like. So, and yeah, with this prototype, I was also experimenting to hear, like, to put the different microphones in different places to see how it sounds like in a specific part of the instrument. And yes, so this is like a little example of how the newest one sounds just like the pure bowing sound, which is just where just one string is bowed, and you can hear lots of overtones like harmonics. Yes, so
Tabita,
then,
you've got about 1 minute left.
yes, so just generally the idea is that I want to, like, the utopia is that I want to go bigger, and like I would like to find out if we can make houses be playable like musical instruments, and also then to go even bigger and think of like cities as like instruments. And I think that's it. Yeah, so thank you.
Thank you so much, Tabita. It's a really incredible and inspiring project, and especially for me, since I kind of saw an early version of this project when we first met a few years ago, and it's just really awesome that you've managed to carry it through like this. So yeah, again, please feel free, everyone, to post questions in the chat for Tabita, and maybe I'll just go first and ask. So in Andrew's talk, he mentioned that his relationship with the magnetic resonator piano is that it's kind of reached a stable state, and he's kind of just tweaking it based on feedback. And I'm just wondering, in comparison, where do you feel like you're at with this project? Do you still feel like this is very much a beginning and it's going to go in lots of different directions, or do you feel like its identity is kind of starting to solidify maybe?
I feel like the principles are definitely solidified, but it's still at the beginning in terms of like I've only really explored one type of tensegrity and really simple systems, and yeah, so I think it's still the beginning, but it's at a good point where it's proven that it works very well sonically. So
I'm really sorry, someone's just rang my doorbell. If anyone else wants to jump in with a question, please go ahead.
Yeah, if you have any questions, or if anybody would like more like information about something, you can also like write me an email or just like send a message.
Can you say just a few more words about the house that you would want to build?
Well, the silver prototype would be like the structure. Like the first idea was to go more on the like to change the shape of the thingy that I'm currently. So the thingy I'm currently using is more like what I'm currently using is more like a tent kind of shape. If you want to see it in a building kind of view, and I would like to make basically this one but bigger, and then explore with like a fascia like structure like we have in our body to cover it, to make it also like a protective thingy. So basically the idea is to scale it up. You could also do it with like if you were gonna make a bridge. So I haven't got any precise plans yet, rather than scaling it up and trying out this new system and making it work, and then you can think about how to continue from the big model and how you can extend it. Yeah, I think this one.
All right. In the absence of Jack, I will take over as the chair, and I'll just get back to Adam and see, Adam, how is your setup now? Would you like to try?
Yeah, hopefully it works.
Okay. Well, Tabita, thank you very much for a brilliant presentation and fascinating work. I really look forward to see more and work with your technology and work with you in the future. So thank you very much. And yes, over to Adam.
Thank you. So now I sort of know how this goes, hopefully. Yeah, so I'll just briefly recap there that I come from a background in, I'm a double bass player, come from a background in improvised experimental music, and have been exploring the double bass as sort of like a timbrally, spectrally complex instrument for quite a while. And wait, actually, I need to unshare and then share again in order to allow for video. Apologies. Okay, so Halldór Ulfarsson and I designed this feedback actuated augmented bass 2.5 years ago. It looks like this on the front, not much different than a regular double bass, except that you note it has some electronics underneath the fingerboard, and you can probably also see the pickups under the strings. And the idea, as I said, was to use Halldór's halldorophone concept on this instrument. So the way it works is that the strings of the bass, the signals are being picked up by pickups. That signal is then being sent to Bella, a microprocessor that does signal processing. That signal is then amplified, sent to a speaker that sits in the back of the instrument, like this. It was terrifying the first time Halldór drilled a hole or cut a hole into the back of a bass and put it in, but we were happy to find that it actually works without the instrument collapsing. Well, the speaker then, apart from emitting sound as air pressure waves, also vibrates the double bass body, which in turn vibrates the bridge, that vibrates the strings, and then like that sort of completes the feedback loop. So the instrument goes into a self-oscillatory state with the strings self-oscillating. So that's very exciting for a double bass player to have this instrument that basically plays on its own. But there's also some things about string feedback that it has been brought up by Chris Kiefer and Dan Overholt and Alice Eldridge in a recent 9 paper, which is that these strings, they tend to lock into these very strong feedback loops that sort of often overpowers the other strings. So often, at least as my experience on this instrument, you get like one string or one note feeding back very strongly, and it can actually be difficult in the long run to generate variety on the instrument, even when working very carefully with the amplitude. So here I would like to talk about one very simple signal processing algorithm I developed very recently and premiered at a concert last week that sort of attempts to kick some, let's say, instability or metastability into the instrument that allows for the performer, but also the instrument, to explore like different modes of behavior. And when working with signal processing on this, on the feedback actuated bass, I was inspired by the double bass own, let's say, internal acoustic feedback loop. When you play an acoustic bass with no amplification, there's also feedback behaviors happening inside the instrument, with the strings being revibrated by the instrument body, or that you can cause feedback loops to emerge between the bow and the string, for example, which is something that happens when you play multiphonics, for example, on the string. That is like split tones that cause several tones to arise from one pitch. So I was interested in how to apply this to signal processing, this idea that it's not, the instrument doesn't just take input from the performer and translate that into sound. It also applies its own behavior in a way. It modulates what is coming in and causing something else to come out. It's not just gesture translated into sound. It's something more. So another thing is, when working with signal processing on this instrument, is because I use both hands when playing, I don't really have access to fiddling around with processing variables much. And therefore I decided that it should be up to the instrument itself, or up to the signal processing itself, to do this. And that can be done if you, for example, let the instrument be able to observe, could be things happening in its environment or its own internal state. So here I'm using auditory analysis, tracking pitch or amplitude, and using that to drive signal processing variables, so that I'm able to let the instrument make decisions on its own. But again, since the double bass doesn't always just translate what comes from the outside into sound. I work with an sort of a signal processing architecture. Oh, there's the speaker again. A signal processing architecture where instead of listening to the audio coming in or the signal from the strings, the processing is sort of listening to its own output and then feeding that data back into itself. And it's just an important thing to mention because it will explain why certain things behave the way they do. In a way, this causes the instrument to, let's say, create its own internal representation or its own internal world. I will play some, I'll get to playing some examples, but first I want to talk a bit about this algorithm that they're based on. Something that I also found could be a bit frustrating with working with this kind of string feedback is that because it locks into these string oscillations, it often it very much centers on the whichever fundamental frequency you're playing. There's not that much possibility for exploring other, let's say, timbres when the feedback really gets going. So this algorithm uses a comb filter in order to try to amplify certain other resonant properties of the signal. And a comb filter is just a very short delay line with feedback, which we see here. But what happens when in this particular implementation is that as I said, I let the comb filter listen to itself. And I should say that this happens since I have 4 strings. I'm doing this, every string has this algorithm implemented. So it's not the sum signal of the 4 strings. It's every string is individually processed. So for this comb filter, in order to define the delay time, or we could also say the resonant frequency of the filter, I make it listen to its own output and track the pitch, or in this case, something like the spectral tendency, which is kind of a time domain version of a spectral centroid that has been developed by Dario Sanfilippo. That is then routed back into the comb filter. The reciprocal of the track pitch is routed back into the comb filter and would then define the delay time. However, in order to avoid the filter or the filter changing pitch all the time, in order to avoid a continuous tracking of pitch, which can give a weird Doppler effect in the signal, I decided to let it only be triggered by certain behaviors of the instrument. And there I used the measuring the absolute value of the difference between a fast and a slow amplitude tracker. I then integrate that, and whenever it exceeds a certain threshold, it triggers a recalculation of the delay time as the reciprocal of the spectral tendency. That means that every time that there's a great change in amplitude, that can either be that the amplitude goes up or down, the delay time of the filter changes, and that can give some kind of interesting behavior from the feedback. In addition to that, I also chose to not only use the fundamental of the track pitch, but also multiplying it by a randomly chosen ratio each time it is triggered. And that ratio corresponds to the lower harmonics of the track pitch going up to the 9th. And that means that the bass also sort of starts exploring its own harmonic range in relation to the frequency currently being played. Of course, there's also the possibility that it tracks the wrong frequency, which I only find sort of interesting and can generate interesting behavior. Now, there's 2 other things that features in this filter. That is the feedback coefficient, the amount of feedback in the filter. And in order to not have the filter ring too much all the time, I again use the calculation of the difference between the fast and the slow amplitude tracking. That is the change in amplitude, we could say, and using the deducting that from a feedback of 0.9. That means that every time the amplitude changes, the feedback actually decreases, and that in the case of like a increase in amplitude, that can be useful because it prevents the system from going into like overblown feedback behavior. The last thing is the feedback sign, which can cause the feedback of the filter to be either in and out of phase, and that is the amplitude of the filter routed through a Schmidt trigger that then causes the amplitude to be either in or out of phase. I'll proceed to some examples now. It's only to illustrate how that it's a very simple algorithm, but it can lead to quite interesting emergent behavior, which we can start listening to now. Oh, I should say that I would have wanted to play this for you in person, but since that it's not possible to be all in the same room, this is instead from last week actually, when in Copenhagen, where many of us, or some of us, were at a symposium. And so this is like a premiere of a performance with this particular algorithm. And because of the low light, the image is fairly grainy. And I can recommend that you use headphones because there will be some like low frequency stuff going on. But here's like the first minute of the performance. Okay, so I'm basically not doing much in this part of the performance. I'm merely holding down pressing down the lower string and letting the instrument and the algorithm and the interaction between the digital and the physical domain take care of sort of creating this pulsating behavior. What I found when I designed this algorithm was something I wasn't really expecting, but it sort of allows for like these sort of like rhythmical beatings to start happening. And I think, again, it's a bit difficult to say sometimes what is causing what in these complex systems, but I think it's the phase shift of the feedback causing this to happen. This will be more clear possibly here. Oh, wait. Okay, so there I found that I can, by changing the my position of my left hand holding down the strings, by changing the position ever so slightly, I can cause changes in these like rhythmical patterns. And because the instrument in itself, like acoustically, is like fairly nonlinear in its behavior, like amplitude will vary quite greatly depending on where you play on the fingerboard, which in turn affects how the filter responds. And if I go to the next one, this may be more obvious, and also where it sort of like sometimes starts creating these like metastable rhythms that are not continuous, but are like recurring, unstable rhythmical patterns, and also allows for the creation of polyphony, playing several pitches at once, which can also be a bit of a challenge on like with a purely analog feedback of string instrument. Which is this one. No, sorry. Not that one. This one. And the very last example I want to play is what actually happens if I start actually playing the bass, actually bowing, which is where the filter will cause like the string to explore like different upper partials of its fundamental frequency. So that comes here. This comes. Oops. Yes, that was all for me. Thank you.
Thank you very much, Adam. Yeah, wonderful presentation, and so interesting to hear all the different examples. So we're going to go to a break in a moment, but does anyone have any questions for Adam before we go to that break?
Andrew has a question there. I can see. I got one
Go
too.
ahead.
Yeah,
Great, really interesting presentation. Thanks very much. You said that there's one of these feedback processes in place for each of the different strings. Is that right?
Yes, what the algorithm, like
Yeah.
the whole filter is applied to each string individually. Yeah.
Do you find that there's any interaction then between the strings acoustically, like where one of them kind of kicks the other one off and they have a conversation with one another?
Yeah, definitely. Yeah, and it like that's again what's interesting about it is like it's really hard to predict. You don't have to like, even if you move your left hand a tiny bit, suddenly one of the other strings will start feeding back and then cause, I guess, the amplitude tracking of the string that you're playing currently becoming a bit like influenced by that, and they can enter into these like quite complex interactions between the two or three.
Yeah. That's really cool. And just as a comment, I think that this algorithm that you developed looks really, really interesting. And I mean, I think it's really well motivated. And I'd be curious if you could actually like collect some kind of recording of what it's doing as it goes along, so you could kind of see the different outputs kind of accumulating and triggering and flipping. I mean, because I think this could be really valuable for other people to explore for themselves, and to be able to look inside a little bit to what it's doing.
Yeah, sure. That's a great suggestion. Thank you.
So you had a question?
Yeah, it maybe follows up a little bit from Andrew's. So it seems to me like you have many feedback systems there. You've got the audio feedback, and you got your interaction with the instrument, but you also have the kind of control feedback there. So there's a kind of control line as well. And I'm wondering, in all these feedback loops, you are probably the only conscious system there. And where is your consciousness when you're playing this? Do you feel that you're thinking about the graph that you showed us, what things are happening in terms of the control feedback, or are you just thinking about the sound, or where's your attention when you play this instrument in terms of understanding what's happening in the feedback?
Yeah, it's a lot right here, I guess, like in the fingertips. Depending on what's going on, but you know, even just like like you have the string and then holding it and feeling that kind of like sensation of the string moving, like creates an enormous focus right there. But then when you add the bow and you start bowing, then it sort of like moves to the hair, or like it's a very no, I'm not thinking about about signal processing when I'm playing, but it's sort of becomes distributed all across the instrument, of which I'm also a part.
Thank you. Yeah.
Okay. Tabita?
Yes, I wanted to say something maybe similar, that I don't understand anything about the algorithm, and like I know that you have a speaker in your instrument and mine doesn't, but the effect that you get out of it is kind of the same, like you're getting the wolf notes, or you play one and the other one, like the other string is getting activated as well. So in that the instruments are quite similar, and I would say that definitely like the strings are probably activating themselves. And my instrument is the same. When you bow one part and you move the bow slightly to a different place, because in my instrument the bow is also like the only touching point, so you're kind of bowing the overtones.
Yeah.
That you're probably very much like at the point where you're bowing, like in the bow hair, or if you're also using the finger, like feeling the vibrations. So it's very similar in that sense, and I get very similar effects. So I just wanted to make that as a comment.
Yeah, it's a really good point. It's also something I wanted to retain when we started working with this feedback instrument. I wanted to keep that sensation of actually playing an acoustic instrument that is like really precious to me, and just see how where that would go when you introduce other variables into the whole thing. In a way, maybe the difference is more subtle than we actually think between like electroacoustic and acoustic instruments.
All right, thanks everyone. That's the end of the first half of our presentations. So we're going to take a 10-minute break. So we will, well, let's say 7-minute break. We'll come back at 15:25 UTC, and that will be with Halldór and Guðmundur Steinn talking about the halldorophone. So don't lose the feed at this point. We've still got a lot of really cool stuff to come. See you in a moment.
See you. Thanks.
Yeah, Halldór, I think just go ahead and do a quick test if you want. You're on mute as well, by the way. No sound at the moment. It's when you do share screen, it gives you it's like the share sound option when the little window comes up. Does that make sense?
It might be in the 3 dots. It was in the 3 dots for me.
Ah,
So when you hit share screen, a window pops up and there's a tick box at the bottom of that window which has
right.
share
Perfect.
sound, and then you also can pick an extra option there to share like higher quality or stereo or something. But then yeah, maybe once you're already sharing, it pops up in the more place.
Yeah, I think I see it.
Yep, hearing it.
Perfect.
Lovely.
Cool.
Okay, I think we're now ready to resume. Hopefully everyone's had a moment to get a cup of tea or a biscuit. So yeah, welcome back to the Moving Strings Symposium. So we have 3 more presentations before we have another break and go to the panel. So kicking off, we have Halldór and Guðmundur talking about the halldorophone, and then after that we will have Davíð Brynjar talking about his autocoder, and then Victor Shepardson talking about no input mixing and his living looper project. So to kick things off, over to you guys.
Hi. Can everybody hear me okay?
Yeah.
So I'm gonna try to do a tight 2 to 3 minutes about what the halldorophone is, because I'm so much more interested in the compositional practice around it these days. And so this is for the handful of you who don't know this project intimately, but these are basically built to feedback string instruments, of which I've built a few different versions and have become slightly better technically, cleaner sound and more refined control features. They kind of grew out of my visual arts practice, so I tended to treat them as props for video art in the beginning. But there is something about feedbacking strings which is intimately familiar and interesting to some string players. So now I think I behave more like a luthier to the composers and performers I have formed relationships over this project with. I want to play you a little halldorophone music, just to give some variation on the sounds that Adam was playing earlier. But he explained the kind of system or the block diagram for a halldorophone-like system quite well, so we'll keep this quite untechnical. Maybe worth adding is that because I've been collaborating with Hildur Guðnadóttir from the start, who is now doing quite well in her career, this project is receiving a little slice of her limelight, which is wonderful, and hopefully there will be some more halldorophone players in coming years. So I'll be vulgar and speak over this beautiful music. This is me, Helgren, playing Jóhann Svensson's composition in 2014. It's for 2 instruments. The other instrument is one of Erkki Kuronimi's original 2 in existence, demiers. The guy playing the demier there is Jari Suominen, who has since cloned the instrument with Erkki's permission. But I will stop now and hand over to Guðmundur Steinn, who wants to talk a little bit about composing for halldorophone.
Yes, thank you very much. Hello. Yeah, so I think that when we think about new instruments, that there's kind of 2 trends in the 20th and 21st century. First off, there is a lot of electronic instruments start out in kind of experimental music or even within academia before they evolve into an interface that gets ubiquitous through pop music, etc. Whereas what we usually call the avant-garde for instruments is actually the opposite is true, that when an instrument is falling out of favor in popular music, that's when it becomes avant-garde. Example, the saxophone, the accordion, the vibraphone, and most recently the electric guitar. While Gibson and Fender are going out of business, it's finding its place in the avant-garde. But at the turn of the century, there was this composer group I was part of that had a lot of interest in new instruments, new notations, and the kind of sort of engineering aspects of music, as you could say, in a sort of experimental tradition. And Halldór kind of clicked with our sentiments, because people like me have no skills at carpentry or anything such. So yeah, so I've been watching this instrument since it was in its very embryonic phase, and what you're up against is pretty much the same as with any instrument, except that most composers, educated composers, we have such mechanized ideas of instruments that we forget how organic they are. For instance, most instruments, whether it's a trumpet, a flute, or a voice, you cannot ask an instrument to go straight to a very high note without any preliminary. There's all kinds of things that maybe they're possible, but you just don't do them because they're not gonna work well. They're not really in the nature of the instrument. And people understand that. And the same thing is true that if you write something very delicate like multiphonics for certain wind instruments, you understand that some of them will need time to speak. The halldorophone is the same way. It has these characteristics that you kind of have to understand. And I think a lot of composers, they try to think like not what this is, but what they can impose upon it. And I think it's like one trumpet player I heard lecture talked about how young composers, they would ask, what can you do, instead of how do you do what you do? And I think that there was a kind of aha moment for me when I was working on a solo dorophone piece, and people were fiddling around with the dorophone at this workshop, and Halldór said at one point, aha, now this is starting to sound like a dorophone. And so basically, this is not just a cello with a feedback mechanism. This is, that doesn't really give you the right thing. It's its own thing. It has some cello elements, but it is more, it's rather a feedback string instrument with some cello features in it, I would say. I would turn the paradigm around. So what I want to do is I want to show you, if I can share the screen. This is the, can you see this?
Yes.
This is the, this is the score of my suite for dorophone, for Hafið og Örninn from 2014. And in this, I'm writing separately this is very much, this looks very academic and having it in many layers, but it's actually, I thought of it as very practical in the sense that this is based on me fiddling around with the instrument a lot and finding sweet spots and what I thought the instrument was very good at. And so it's written for each of the 4 faders, which is, there's a feedback fader for each of the strings. And then there's a clef, for where the notes are actually happening, where actually, in other words, where the player should put their fingers on the left hand. On the right hand, instead of, sometimes it's using a bow and sometimes it's on the faders. And the score will indicate. And then there's these 2 pedals, volume pedals for each of the speakers. And on the bottom, there's also a master volume knob for all the faders and the whole mechanism kind of on off. And I'm rarely using all of this at the same time. It's just the piece goes through on an animated score in one go. And I'll play you some example.
Sorry, is it just me or can we hear?
No, we can't hear anything.
No, Guðmundur Steinn, can you unshare and click a tick box that says share audio or something when you do it again?
Okay. I'll
share again, and there's a button at the bottom.
Oh, right. Yes, share sound. Okay.
Yeah.
Gotcha. Okay. I mean, I could pick any spot here. Wait. No. This one, for instance. Yeah. Okay. And so on and so forth. So I think that the thing with this instrument is that most of the things that it's good at, you cannot decide that it's going to happen like this and this. Like feedback has to be given time to start. You have to give it a kind of a slow time frame for the feedback to start. You know, it's like starting a fire, and once it's there, you can control it more easily. But it's kind of like starting a high note on a flute. Like you have to kind of climb up in a scale, and then you can do all the tools. I'm speaking composerly language. I'm sure more people here are kind of technically oriented, but I'm making the comparison of more traditional instruments. But it's just the physical experience of feedback and how organic and slow it is very essential to being able to write, because a lot of people that try this a little bit, the dorophone, they tend to think, oh, this is completely random. But of course, it's not completely random. A flute is not completely random either. It's the whole bump system of the keys. There's so many compromises other than just the tuning. Like and different octaves would sound differently if it wasn't for these micro little things in the compromises in the size of the holes and so on. With this, there's an additional layer that is romantic for me, because that it actually, I feel that it connects also to David Tudor and this idea that you're controlling feedback in a live setting, like he would do, going from being a piano player into being a feedback control player. He actually abandoned the obvious theater of virtuosity, still doing something extremely virtuosic, but he himself understood the intensity and the virtuosity of what he was doing in his later years. And I connect this instrument. Here you have the feedback and strings coming together in a way that's very hands-on and practical and repeatable, replicatable. Like each Autocoder I've tried is different, but they all have, like this piece, for instance, could be played on any of them, as far as I can tell, and it would work, even though there's a little bit of some things would speak much more on one than another and so on. But that's the same also for most instrumental pieces. Okay,
we're,
I guess
running out of time, Steinn.
Yeah.
Maybe we should leave a little time for discussion.
Okay.
Thank you.
All right, that was amazing. Thank you so much. Questions for the halldorophone duo?
Yep.
So we have a hand from Adam. Go ahead, Adam.
Thank you. Yeah, it's a question for Guðmundur. It's interesting that you're writing for a solo instrument, but your notation is almost orchestral. How what was your process of coming to this kind of notation?
It's not. Well, I guess this it's not unprecedented in new music. There's composers like, say, Mark Andre or something that have done much more complicated things, solo instruments with all these layers written in a way that's not necessarily in of itself practical, but almost conceptual in a sense. I'm not sure, but for me this was actually practical, because I after trying all these things out, I thought actually in comparison I can show. Actually, I have another piece that where I used the Autocoder, which is an opera. And here it is condensed. Its bottom line is the halldorophone, and it's very different, because here I have explanations and it's just the tablature. Like each of these lines is a different string. The string sounding is the square, and then the triangle is the finger. So then I was trying to compress the information, and here you have two strings sounding at once, and the fingers going almost parallel but not quite. Whereas in the other one, the focus was more on the faders themselves. Whereas, so because it's a solo piece and there's a lot of focus on the player, I think he has time to learn this, and there's nothing else that has to be on the screen. So I don't think that it had an overload of information, because you see there's always only like 3 or 4 lines at most, and I think it's practical. Like this here is the knob going while the other is the finger, and I think it's practical and clear actually. So yes, it treats it a little bit as an orchestra, but I like that. You have 4 strings. There's a lot of big sounds that you can get out of the interaction of the different feedbacks, and it can have predictable and unpredictable results. Yeah.
Thank you.
Yeah.
All right, I think that's all we've got time for this presentation, but we'll see these folks again in the panel. And next we've got Davíð. So please go ahead with your video.
Yeah, hey, thanks. I pre-recorded mine last night because I figured I would go over on time otherwise. So some things in there got a little bit covered by Adam, Dóri, and Steinn. And so actually will be helpful to have had that. So thank you guys for getting all of that in. Yeah, let me just get the screen share going on that. Share sound. And just let me know if the sound doesn't come through. I'll turn my video off.
Yeah.
Hey, just
Yeah,
wanted
we got
to
sound.
give a quick explanation why this is pre-recorded. I have a lot of demos in here, which I might have been able to pull off live, but not a chance I can do live on Zoom. So yeah, here we go. Today, I'll be presenting some early research for a new piece for the halldorophone, which is an electroacoustic string instrument developed by Halldór. I'm going to assume that Halldór already covered most of the basics, but just in case, here's a description of the instrument. The halldorophone has 8 strings, 4 regular strings and 4 sympathetic drone strings that move along with the vibrations of the instrument's body, sustaining and reinforcing certain pitches. The instrument feeds the vibration of the strings back into the instrument via a built-in speaker. This forces the string of the instrument into a feedback loop, resulting in any open string or sustainedly fingered string that has an open signal path, that is, basically we allow the signal through to start droning for as long as the finger is held in place. The performer has onboard control with faders over how much of the sound of each of the top strings is fed back through the instrument, as well as of the sympathetic strings as a group. The signal from each of the 4 sympathetic strings can be individually broken out of the instrument's signal chain, and the signal for the 4 upper strings can be broken out as a group, which is the inverse of the faders that are actually on the instrument. The signal can then be processed and returned back to the instrument, either individually in the same grouping or as a mixed signal. So we can basically intercept the feedback loop and do any sort of operation that we want in there. One thing is that by placing a filter in the signal path of the halldorophone, we can strategically control which harmonic of a string will resonate. If you then tweak the gain of the speaker high enough, we can force it to activate a feedback at the given pitch. Let me just put on a little example here. These are the filters affecting the feedback signal path of a single string. A generative AI, an artificial intelligence, in the signal path that manipulates this filtering, we can create a virtual body for the instrument, allowing the instrument to perform on its own or augment the response of the instrument when played by a performer. The AI uses an algorithm I've been developing called an autocoder. It's an implementation of a variational autoencoder, which is a neural network capable of learning a spectral representation of a sound file and synthesizing a new sound based on the trained model. It can be described as a same in, same out structure that takes an input, runs it through one or more hidden layers, and then reproduces the input as accurately as it can. The network consists of 2 separate parts. One is an encoder that encodes the training data into a very compressed representation called a latent vector, and a decoder that decodes the compressed information back into the space of the training data. So just to clarify this, we take a sound, we do a little FFT analysis, get a picture of the spectrum of it, run it through the encoder. In our case, we get 8 values out that represent the whole spectrum. These values don't really mean anything, they just affect how things come out. You'll see them later on in examples. And then the decoder takes these 8 values and decodes them and returns to us the same spectrum that we gave it in the first part. We can then feed arbitrary information in as the latent layer of the network and have the decoder part of the model decoded into the space of the data we trained the model on without providing it any data there. So basically, if we manipulate the middle of this network, we can ask it to give us an output that is representative of what we showed it to learn in the first place. I have a couple of examples of this. The first one is an Enya song. Given that this is pre-recorded, I'm just going to play the output of the autoencoder, not actually the input. Just, don't want to get in any trouble here. So yeah, let's listen. let's take an example where I feeded Tristan and Isolde the 3 minutes from, this is like Liebestod, which is pretty late in the piece. Yeah, here we go. And then finally, I've fed it the complete first and second book of Monteverdi's madrigals. So this here is a model that it trained upon. This is about an hour-and-a-half long model. The other two ones were 3-minute models or data sets that went in. We can also use the network to convert a discrete input space into a continuous one. This, for example, would be a set of reverb impulses, which are just individual sound files. And if we feed that as training data to the model, it can produce a continuous space that can be used for the filtering stage in a hybrid reverb algorithm, giving us a lot of different reverb filters or reverb sort of colors that aren't actually present in the original input, but sort of are mixtures of the main components of the data set that went in. Here's an example. Also use models that we use for the generative synthesis for this filtering stage, basically doing kind of classic vocoding. Except in this case, the resulting cross-synthesis is created with a dynamic generative carrier signal, which is constantly producing sound based on the input space that we gave it in the training data. Here, for example, is the same drum loop going through the Anya. All this software is fairly easy to use. There's a little bit of a threshold to install it on your laptop to begin with, but after that, it's pretty straightforward, and it's up on GitHub /Franzson. If anybody wants to try it out, just be in touch with me, and I'll walk you through it. But back to the original plan of this piece. If you place this AI in the signal path of the instrument, using convolution between a modular signal coming from the instrument and a carrier signal coming from the AI, we should be able to generate a shifting filter structure in real time. So we basically should be able to get the instrument to speak on its own, make decisions based on what it's heard before. The generated part of the AI can be trained on moments that I specifically want to have happen, as well as a material captured via improvisation on the instrument itself. as the output of the instrument can be used as filtering material. So, for example, here's a recorded part of the instrument. This is just the raw audio coming out of it. And here's a video of the instrument, a single string playing back using a model for filtering and playing on its own. Just a caveat, again, single string, so we're only going to get harmonics of that specific string, but you'll hear multiphonics, multiple pitches come in and out at the same time, things like that, which we're basically coaxing the string into doing with this generative filtering. The AI for the instrument will be placed in a Eurorack module, so that this component of the piece can be standalone without the use of a computer and an interface. So basically, you should be able to have the instrument, you kind of hook out of the instrument into the Eurorack and back, so there's no other component. The module is still in experimental form, but sort of formed. Again, if anybody wants to try to build one, I have the PCBs, I can ship you one. I'm not going to guarantee it's not going to fry your equipment, but probably won't. Also, this is not a high-end design, but it runs on a Raspberry Zero 2, which is a brand new little Raspberry, which seems to be powerful enough to run this AI pretty consistently and at relatively okay quality. The other thing that I haven't really gotten into is, like, for this first iteration of the piece, I'm thinking of it as standalone. The instrument itself playing itself, but as time goes by, I hope to add a performer into it where the idea is that you're not just having a generative instrument, you actually have an instrument that is changing how it responds in real time. So let's say you're playing something, you want to try to get a drone on the open C string. It happens to only want to drone the 7th partial because that's what the model is telling it to do right now. So you as a performer would have to then adapt, listen, respond, try to find things that work with that. So it's no longer a sort of singular thing where, oh, I'm going to tell the instrument everything it's going to do. It actually becomes a complex system where you and the instrument are actually having a dialogue in real time, which is happening right there. So hopefully the musical experience stops being to sort of listen to what I'm doing and more being like, hey, we're here together trying to make something interesting happen. Okay, thank you. I think that's all for today.
Okay, yeah, so that was that.
Wonderful, thank you so much. So once again, we have a bit of time for questions, and yeah, if you would like to add one in the chat, then please go for it. Someone has asked David if you might be able to share the URL for your GitHub.
Yeah, it's just like, I'll write it in the chat, so it'll show up there in a second. It might need an S and HTTP, I don't know, but there we go.
So yeah, this is really exciting and cutting edge work, and it ties in so amazingly well with what we're hoping to do in our lab as well. And something that always comes up for me if I'm involved in something that feels very much like research is this kind of emotional strain of, you know, you're kind of spending so much time deep in the technology, and I find myself sometimes wondering, am I ever going to make music with this again? But you seem to be balancing these quite well, and I just wonder if there's anything you'd like to share about your experiences with that.
I mean, I do think I'll have to credit that to Halldór. He's sort of taught me through the years to sort of, you rapid prototype things and then you test them and you get that feedback going so that you aren't continuously just designing and building things beforehand. Because I do think like fits very well, like where Halldór fits very well with the lab mentality in general. Because like you say, you die on the inside if you don't have that. Like this is a piece that will take almost a year to finish. It's being premiered in October next year. And you know, there's a Wayfield speaker system with it that resonates to the instrument, and all sorts of more technology going on there. And if I would just finish the technology first, I would probably have like a week left to actually write the piece. So, you know, and also it's that if it's that, like you really want the piece and the technology to integrate into a single thing. Of course, the downside of that is it's not necessarily usable by anybody else if you do that, which is why I created the library partially separately. But at this point, everything is being sort of adapted to my needs, and that's just now its own thing that is sitting there. So if somebody finds any use for it, for God's sakes, do something with it, because I love what it can do with all sorts of inputs, but it doesn't necessarily tone with my own aesthetics. So yeah, I'm pretty sure there are good things to do. And I mean, there are a lot of pretty amazing things you can do as well with taking other input and run through the pre-trained model. So, you know, there's all sorts of concepts that just hasn't even been touched in this kind of stuff.
Awesome. Well, we're all very grateful that you're plumbing the depths of this new domain for our entertainment and benefit. And I think we should move on to the final talk, and that would be from Victor Shepardson. So over to you, Victor.
All right, thank you. Let me set up my sound. Back. That should do it. Can you hear me? You're hearing me and seeing my OBS. All right, great.
Yep, all working well.
Wonderful. Hi, so I'm Victor. I'm the current only PhD student here in the Intelligent Instruments Lab. And today I'm just going to give sort of a demo tutorial on no input mixing and what I do with it, how I do it in this particular case, which I hope will be interesting for people who are used to feedback instruments or maybe have played no input mixer before, to kind of get someone else's nitty-gritty on it. And I hope we'll also have the flavor of playing a feedback instrument for anyone who's interested but who hasn't really jumped into that. Yeah. So the no input mixer, I have to apologize, doesn't contain any actual strings, but it does contain quite a bit of feedback. We say no input because there are no external
Victor, you just went on to mute for some reason.
do that, but anyway, you
back.
Can hear me now, right?
Yep.
Quite bizarre. I don't know how that happened.
It was me. I was trying to make you to make the video big. Are we?
Oh, I think you just have to maximize your windows because I'm not screen sharing, so it's not going to maximize itself.
Yeah, sure. Sorry about this.
Yeah, sorry. So this is taking a mixer, which is supposed to be this kind of neutral, super utilitarian object for getting sounds to the right place, making small tweaks and corrections to them, and putting it into feedback so it becomes a sound generator and it becomes its own kind of instrument. And a few of the things I love about the no input mixer is it's kind of a way of reusing electronics. Like if you have an old mixer that's unneeded or partially broken, or obsolete. You can give it another life as an instrument, and every mixer has its own quirks. It's somewhat different, so there's kind of this infinite, endless sea of possible mixer instruments just waiting to be played. It's a way of kind of salvaging all the human effort that goes into engineering some new feature or collection of features at some price point on one of these mixers. So hopefully people will buy it instead of the competitor's mixer, taking that and shifting it into something strange. So without further ado, I'm just going to jump right into how this works. So you can see here I have the two main outputs are just going into my computer right now, and I have it patched from this monitor output left channel back into the first channel here, which is then just panned all the way to the left, and everything's kind of at the default position. And so when I turn the gain up, everyone can hear that, right?
Yeah, we can hear it.
Okay, excellent. We get a tone. And the gain always has a large influence on the pitch and character of the tone, but we can also change it with the EQ. There we go, quite annoying. In this particular mixer, we basically have two independent channels. So if we patch the right channel back over to channel 2 and pan that one right, we can get the same thing kind of going on with basically no interference as long as they're hard panned here. And it would be great if that was coming through in stereo. I don't know that it is. In our tests earlier, it didn't. It's not super important. You can see in the oscilloscope over here what's going on in each channel. But the important feature there is that these are basically independent. And one of the ways that we can kind of pilot this into a very sensitive region where interesting stuff starts to happen is to take a setting where two things are independent and just move it slightly out of alignment so they start to couple to each other but kind of maintain their own identities. So for example, if we pan these slightly out of hard left and right, there's this nice region where they start beating and interfering. So this particular mixer has a few more affordances. This one has an aux send, so if I patch aux send back over here to channel 3, we can get a different behavior. I'll leave these down and I'll turn up the aux return on channel 3, so it's creating a feedback loop through the aux, which has its own circuitry and its own kind of character. And we're getting another tone, but this one, especially when the gain is very high, it often ends up in this other regime where we get these nice impulse trains, like so. And finally, of course, there's more stuff you can do than just what I'm demonstrating here, but another thing that's nice is to take this headphone output and get a stereo feedback loop going on. So I'm going to plug these into here to 7 and 8. Is that what I want? Yes. And then a nice thing that happens here is, since this is in stereo, the balance control, oh no, I've lost focus. So that's why I have my little friend here. It usually makes the webcam more inclined to focus. Oh no, he's not the problem. It's this cable, perhaps. Come on, man. Oh, there you go. Okay, thank you. Thank you, friend. So, right, stereo feedback loop. The nice thing about this one is the balance just becomes an independent gain, essentially, for the left and right channel. So if we have that kind of impulse train thing going on, let's try to slow it down a bit. And of course this sounds much more interesting in stereo, but we can start to get two rhythms, which are somewhat out of phase or even in different frequencies. But by adjusting this balance control, and then we could say, for example, bring that other clicky track back in and get an even bigger kind of polyrhythm. Something like that, and then say bring these other tracks in. So at that point, we start to get an interaction between these various channels. There's a bit more going on. Let's see. Okay, so at this point, we've got a whole bunch of different channels in play. There's quite a lot going on, and we've sort of tried to pilot this into a sensitive region. I think I've botched it a little bit since I'm distracted by the talk here. But at this point, for example, like the compressors on this first channel here start to get become very sensitive. Controls. Oh, that's nice. Very sensitive. And there are a number of other just things on this particular mixer. Any particular mixer, you know, is going to have its own interesting stuff going on. But here there's these low-cut filters, and also this very mysterious 2-track button, which logically should do nothing, but ends up being this interesting 3-state button. Even the in-between state does something. So there's quite a lot going on. I think I'm going to skip ahead for time here. Oh, one last thing I would like to mention is, at this point, once we have so much going on, the main two knobs, the monitor mix and the master mix, tend to just develop their own whole long gesture, which you can do in one rotation of the knob. So at this point, after kind of establishing a sensitive network, you can start to sort of play these gestures in a kind of emergent collaboration with the particular idiosyncrasies of whatever mixer you're using. And so one more thing I'd like to mention is, although I find the dynamics of these things, you know, kind of endlessly surprising and delightful, the sounds do start to get a bit boring, in my opinion. A lot of impulse trains, a lot of tones with effectively random pitches, because, you know, trying to get really good at finding notes and playing these things with deliberate pitches is certainly a way you can go, but not the way I tend to go. And because everything's so entangled with the pitch, it's very hard to stay in any kind of tonal or even, you know, harmonically sensible world on a longer time scale. Of course, you're constantly tuning the different channels to each other and so on. So one thing I like to do is just post-process this sound. So not introducing any further feedback loops, but there are things you can do that even pull more detail out of this signal, pull things out of the waveform that you can't normally hear. And one of my favorite tricks, which I'm just going to demonstrate right here, Super Collider, we've been hearing it so far plain, just running through a limiter. And now I'm going to introduce this method of using a zero crossing frequency or pitch detector, very crude pitch detector, which operates at the waveform level, and a frequency shifter, which is even cruder than some pitch shifter. It ends up sounding like amplitude modulation because and rather than like shrinking the whole spectrum to do a proper pitch shift, it simply moves things. So what we're going to do here is crudely detect the fundamental frequency and then crudely shift whatever happens to be at that frequency to a target frequency, which in this case is 200 hertz arbitrarily. And this does a couple things. One is like I said, it reveals a lot of information which is in the waveform that you normally can't hear, and kind of even enriches the whole sound. And the other thing it does is just gives some like slight modicum of a tonal center, and also explodes all these kind of samey harmonic sounds into wild inharmonic sounds, which to me is a much more interesting, much larger sonic terrain. So here's what that sounds like. Going back to just 2 channels. So I just did the switch over there. So lots of nice crunchy effects happening at the waveform level, and lots of interesting sounds. All right, and I think I'm pretty much at time here, so I'm just going to stop there. Yeah.
All right. Thanks very much, Victor, and a really fun way to end the talks this afternoon. Yeah, any questions, sorry, for Victor before we go to the panel?
Yeah, I got a question. Beautiful sounds, Victor. Very nice. I was wondering if you have considered putting in a physical model of strings into your loop there, into your feedback loop, considering the theme of the workshop. It could be quite interesting. Okay, I have support with my question here.
Yes, yes. It's definitely something I've done before, is to have feedback through the computer with something with a longer delay, which takes it more into that acoustic feedback world where those things actually happen slowly. But I figured I would just present it, as itself, where it has really a different character just because everything's so fast, and it has a bit more autonomy also because things stay put where you leave the controls. Another thing which I have done is actually, I completely forgot about this until right now. I should have probably shown it, but to just trigger like a Karplus strong Pultz based on what's happening again at audio rate, so you retain all these really fine textural details and crunch, but you can take it into another completely different, even very tonal sound world if you want.
Thank you. Nice.
All right, we've got a question in the chat there as well, Victor.
Yes, has you or anybody composed for the mixer? I think people definitely have. If you look up Toshimaru Nakamura, is a major no-input mixer player, I think one of the first people to do it, and certainly someone who's spent a ton of time and made a ton of records doing it. And I think he uses these much bigger mixers often, which can be played in a more deliberate way like that. I like this little guy just because, although it's maybe somewhat like the halldorophone, it's got kind of a approachable number of controls and yet a very, very large space to explore. Personally, I don't consider myself very much of a composer. If anything, I would call myself an improviser or producer or something before I would say composer. So it's not really something that I've attempted to do. I think it would be really instructive just to spend time trying to reproduce the same thing reliably. I'd probably learn a lot about the mixer. Like, I learned a lot about it just preparing this demo. Yeah, it's a bit of a rambling answer, but...
Okay, well, maybe now is a good time then to have another quick break, and that will be the end of the presentation session. And Thor will be chairing the next session, which will be a panel featuring all of the presenters that you've just heard from. So that's bye from me, and I will hand you over to Thor to let you know about the timings of this short break.
Thanks, Jack. If I remember correctly, it was supposed to be at 25 past, so that gives us 6 minutes to make a cup of coffee or tea or whatever. And should we then just meet here at 25 past 4? See you then. So we should be starting soon. It would be great if the presenters would join me here on this stage.
We're gonna get some light on here.
It's dark in there. Guðmundur, Steinn, and Halldór, for some reason you're not on the website here, but it would be great if you could join me as well.
Yeah, sure.
It's
getting darker.
Do you have no light from your laptop screen?
Not enough.
And is Halldór there and Victor coming? Tabita? Is she around?
Yes, I'm here.
Can you join us?
How?
Just show yourself by the video.
Yeah, it's on.
Oh,
Hello.
there. Oh, yeah. Okay. We're all here except Halldór then. He's probably making tea. So, thank you, everyone. This was absolutely fantastic presentations. It's so interesting to have these quick presentations to get an insight into how you work. And of course, in many of your works, we're able to read the papers, check the website. I have just, for example, looked at the repository of Davíð, and there's a lot of great information just in the README file of the project. So there's ample information to study further. But what I like about these short 10-minute, 15-minute presentations is to get these quick insights that can lead you on to other things, and also just to learn what people think are the important aspects of their work. And of course, you choose a certain aspect of your work whenever you decide to present something in 10 minutes. So we had Andrew talking about, for example, the reception and the notation of his instrument. We had Adam talking very much about the algorithms and how the feedback works in the instrument. Guðmundur Steinn had a brilliant kind of talk about the composition on the halldorophone, about notation and so on. And Tabita showed the beautiful kind of sculptural quality, and the idea of playing a sculpture like that I've found very, very fascinating. Victor's work was really interesting, and it was great to see live demo of it. So there's so much to talk about here, and we could talk about, for example, notation, and that was actually a theme that came up, and I noticed that I think somebody asked Victor whether whether it's possible to notate for the instrument, or if he had considered notating for the instrument. And Victor said, I consider myself more of an improviser rather than a composer. And I find this a really interesting kind of dual position. And I was just wondering if we could think of some instrument actually being more composable, or whether there is an axis where it's easy to compose for a certain instrument but difficult to compose for another instrument, and whether if that's an axis, whether it's more than appropriate to be improvising on one and composing on another. I think we're all in this meeting here, we're all questioning the notion of the composer and the performer and this separation, and that's nothing new. I think Guðmundur Steinn talked about the tutor, and this has been happening since the 70s, of course, this questioning of that separation. But now we're focusing so much on the instruments, and maybe I could throw it up as a kind of question here to my fellow panelists whether with how they consider their instruments. You know, are these instruments for exploration? Are these good instruments for composing for, or would you think that the person improvising, playing on your instrument, is it more of an instrument of exploration rather than following the notated score? This is maybe a question I would put to all of you, and we can start the discussion on that. Tabita, you have a raised hand.
Yes, I think you would also need to define when does composing start, and you can also like change how much freedom you give to the player and how. So I'm often trying to work on a more intuitive like imagery as a notation, so which would let you like improvise more while also having like data coming in to play immediately. But generally, I think the nature of music making should be expressive and explorative.
Thank you. Yes, and Adam, you.
Yeah, I think already by virtue of us building instruments and some like also involving writing code, like it's already highly composed in some ways. At least it defines a domain of interaction, and I don't. It makes me think of like Bach's cello suites. If I understand it right, there's no dynamical notation there, or like very little. No like bow stroke instructions and things like that. So I want like in that like that was probably like fairly open to interpretation, at least at some point in time, and has maybe become more fixed. But in that sense, maybe we share some similarities with the music of that period, in that we define a domain of interaction without necessarily pinning it all down.
And
yeah.
Davíð,
yeah, picking up on that, it really feels, you know, you see it very clearly in sort of Adam's work where, like you say, the instrument itself has encoded so many decisions already that you can almost think of the instrument as a piece. The autocoder is a little bit more open, but there still is a very specific sound. I think, you know, it'll be quite a while until we start seeing things really go away from that, because the instrument itself, like as people are learning it, has this encoded quote unquote score in it. And I do think like same thing goes for the AI type things. You can look at them as fully black boxes, but you know, they are prescriptive information about potential actions, which at the end of the day is a score. So just because they're not actually quote unquote notated, it's still, you know, a lot of this is still classically notated in a sense, right? I mean, yes, it's not on paper, but you know, it's very hard to shake the whole part where we're completely free of these pre-encoded ideas. And I mean, that's probably true of instruments always, but I think in part, like quite a lot in this sort of work where we are working with instruments, closely developing them in real time, you are adding things, you're making choices that are very compositional about what you add versus, you know, when you're writing for a piano or whatever, you're like, oh, I'll just do something. Whereas here it is like, well, you know, if I add this to the instrument, what's the outcome gonna be? You know, I think you follow what I mean, but yeah.
Mm-hmm. Thank you. Victor.
Yeah, I think in a similar vein, like when I'm working with the zero input mixer, I have absolutely no interest, like I said, in trying to notate the sound that you produce with it, but just making a patch and figuring out what it can do, and then writing a piece of software that transforms the output. That's an act of composition for sure. Like you're composing a whole terrain, a whole area to explore, and then the exploration is not the sort of thing that it makes sense to notate to me.
Mm-hmm. In a way, it's a certain purpose of these instruments then, that we're in the kind of search mode when we're playing these instruments. For example, let's say, Victor, that you were asked to create and perform the music of a theater play. Maybe your no-input mixer is not the right instrument to use if you want to get the right sounds on the right place in the play, or what do you think?
Yeah, I agree. I would imagine, it would make sense in the scenario if the play were itself highly like improvisational and sort of chaotic, maybe, or, if it somehow fit into the situation of the play, then sure. But yeah, I mean, that would of course be an interesting challenge too. Like maybe you just want to use it like a more conventional instrument. You're going to encounter something interesting and straining to do that, but it's just not the way I've approached it myself.
It would certainly make the play more interesting. Yeah, I wonder what Guðmundur Steinn has to say about this. Yes.
Yeah, I just think that if first off, I think that for me, any instrument, I can't imagine an instrument that you couldn't possibly compose for or improvise on. Like I think every possible instrument would have both potentials, and limitation is not a problem. It's actually more difficult if it can do anything. Then it's harder to actually notate or compose or define, because I think it's a myth. We always tend to think about composition or notation on some scale from exact to inexact, but I think that is an inexact way to describe it. There's always some kind of a characteristic in the notation, and there's only so far you can go in defining something. And I think it was a good point that sometimes the instrument is perhaps in a sense a notation, and that I think a lot of pieces, like some of Cage's work, are actually you're setting up a situation, almost like a board game, or where you're creating the situation for a variety of things to happen. Like you could say that the mixer with this amount of cables is already a score in a sense, in the same way that Variations 2 by Cage is a score. That's just my thoughts.
Brilliant, very interesting. Andrew?
Yeah, I agree with a lot of that. And I think maybe I'm somewhat the odd one out here in that the MRP does have a fairly large set of quite traditionally notated pieces according to Western notation. But I think it's interesting to think about what that does and does not capture. Because I think first of all, it's absolutely true that there's a lot of behaviors and compositional elements that are encoded into any instrument, and that's absolutely true. I endorse the idea of instrument as composition. Then there are the kind of elements that are reserved for the composer. What is it? What are the things that the composer is actually trying to notate and specify, that if those things are observed, it is that piece? And then there is what does the performer bring, which is in neither of those previous two categories. And I think that's true even if you're talking about the cello suites, right? I mean, we can talk about bowing and dynamics, but there's also a lot of other interpretive leeway that any performer would get. I think what I find is that the same instrument can make itself amenable to different approaches to composition or improvisation or anywhere in between, just really depending on the mindset of the musician. So like, for instance, Xenia's piece, Glowing Radioactive Elements, there's a lot of exploratory elements of that little video that I showed this morning of her exploring these scratchy sounds. I have no idea how you would notate that, except to say, let me show you what I'm talking about, and then I'm going to put a little note here that says, find the scratchy sounds. Whereas there are other pieces that are, including my own, that are really quite traditional. Maybe an interesting dichotomy that I've observed, even amongst the notation that I've seen today, is notating what you want to hear or notating what should come out versus notating what you do. Because in some cases, especially if there's some uncertainty about the relationship between what you do and what you hear, which of those is more important? Should you let the instrument kind of decide how it should react to a particular stimulus, or should you make the performer try to search for a particular outcome, doing whatever they might need to do to make that happen? I wonder if anyone else has encountered that dichotomy.
I think Guðmundur Steinn, your yellow hand is kind of hidden in your books there, But I think you've got your hand up, right?
I raised it again because I was just going to answer the question he just asked. That yes, I think this is a very a common dichotomy in notation in general. Like, and I think that composers vary a lot to extremes in this regard. Because when we think of maybe a 19th century piano score, it's not clear when it is notating how it's supposed to sound and when it is notating what you're supposed to do. It's a mix of both. It's kind of culturally encoded and people are taught to decipher which is which. So it's not completely digital. Whereas I think that in a lot of modern music, you tend to see people like, let's say, Evan Johnson or somebody like that, who is an extreme version of what I had, like layers upon layers upon layers, where it's only notating what you're supposed to do and not how it's supposed to sound. And that's almost taking it to a conceptual level, whereas some other composers are very much interested in this, in just exactly the way it's supposed to sound, and even make graphics that represent the sounds primarily, and have more verbal or descriptions of how to arrive at it. Like I think of like Janko Dumitrescu in that respect, for instance.
I think we also have this far back in time with, for example, Bach with his score datura pieces, where he's notating for the instrument, but you detune the string, and then you are basically playing what you're supposed to play, but the sound is different. The frequency is another frequency. And of course, John Cage's kind of prepared piano pieces are actions. They're not the sounds, because you might not know precisely the sound of that string, of course. And yeah, so I think it goes both ways, Andrew, and it's a really interesting thing. I can see Davíð has something to say, but I could maybe point also to the fact that maybe the scores that we could write today, they don't have to be written on paper. They could be video. So you would explain the sound, or I could, for example, try to imitate what Sinia was doing on your MRP by just watching the video of her playing it, you know. So the video can be a very helpful kind of notation device. So yeah, over to you, Davíð.
Yeah, I just wanted to expand a little bit on this, that I find it very helpful to actually think of it slightly more broadly as like you can notate it action or you can notate experience, rather than thinking of it as like, you know, this is how it should sound, this is how you do it. It's you know, notation could be like a description, like Steinn was getting to, of pieces where certain situations are set up. And I do think in those cases, it becomes a really fascinating question. And particularly, I think with these sort of open-ended instruments that, you know, have some encoding in them, of what can happen is that how do you actually notate an experience for the audience or for the performer, or, you know, a mean or a mode of music making rather than necessarily specifics, I guess.
Thank you. That's good. Yes. And Adam, you have your hand.
Yeah, I guess this is also a question of maybe it's more like almost like an ethical question of like, how much do we actually want to define? How much do we want to impose on, even on objects that we build? Like sometimes it's difficult to not see. I mean, let's take Beethoven or many of the great composers, or even Xenakis, but people who like very like notated a lot, right? And sometimes a it's almost scary how much control is being exercised over the music, and it makes me wonder that there's also a certain quality in under determining, in kind of creating a more open space for interpretation, but also for just how we deal even with fairly inanimate objects such as instruments. It's not a completely finished thought, but like I'm thinking about certain decolonial theories on mastery. Julieta Singh has a very nice book on the very idea of unmastery. Jack Halberstam's Queer Art of Failure also addresses these like the ethical questions about how we actually interact with the world, and also the aesthetics of not always managing as we want to do.
I completely agree with what you've said, and I like to think, when I think about notation, about how much your brain can process, well, like how you can read something, and where the like putting out expression, where that's going to be processed in your brain, and how much you can do at the same time. And I think maybe when you compose, one could think more about curating lots of different expressions, or like people doing something, but how to bring them together as like the conductor of something. So I would like that to be like a new kind of notation, which is not like giving very precise instructions in terms of frequencies, but more like actions which then are like create like different experiences together, to also get away from the individualistic playing, but also more towards like the arranging different instruments and people playing together.
Yeah, I thought Hadla Steinn, who was here just earlier, but she probably left now. She said something really interesting in our, she's Davíð's collaborator, and she was showing her work with Davíð in one of our open labs. But she said this beautiful sentence that the performer's body in classical music is the most policed body in the world. You know, there's so much rigid prescription going on that you can hardly, you know, it's almost like here you breathe and now you can breathe out, you know, which is quite an interesting observation. I wonder about this freedom as well that we are then giving people. I mean, a lot of the 60s and 70s composers that started to explore graphical notation and open notation reverted back to deterministic notation after this open period in their lives. And many of them said that this was because a lot of the performers would just resort to playing cliches when it came to these parts in the piece. And I'm talking here about, you know, motor memory or some cliches that, you know, from that they've been practicing, and that the composer thought was basically ruining their piece. So they went back to actually just writing the precise notation in order to escape from this moment of cliche in the middle of their piece. This is an interesting observation, and perhaps what you all are doing, what we are doing here, is to create instruments where it's really difficult to resort to playing cliches. You know, I can't see these instruments really being some bluesy licks or whatever jazz scales or you know, classical patterns in the way that they work. So I think Adam has his hands up there.
Just very briefly, you could maybe also argue, I don't know if anyone ever asked the musicians, but it could also be a response to the composers writing cliches after a while. Don't know.
Yeah,
and
absolutely.
Cliches have a tendency to form with time, so I'm sure we'll have them soon.
But it's also, I guess, if we had this long period of notated music, and suddenly there is this idea of opening it up and so on, many of the performers at the time, of course, classically trained, we're simply not capable of doing what they were being asked to do. And the composers went back to maybe writing notation without giving them, or try to create and emphasize this culture of improvisation. And that's what is happening today, of course. You see so much improvisation going on in new music. So that's a positive development, and I think we would find it much easier to perform these pieces than maybe people in the 70s. Yeah, Guðmundur.
Yeah, I'd like to say that I think cliches, a world without cliches is not inhabited for a long time. I mean, over time, these instruments will hopefully develop their own cliches. And I think we can, with the halldorophone, I think we're already at a point where we can start to talk about halldorophone cliches, that they go hand in hand with the instruments. Because I think, as you were saying with the experimental notations in the 70s, that there were 4 traditional instruments and traditional instrumentalists who took their knowledge to that kind of music. And I think it's experiments in notation do not necessarily always have the intention of going more towards improvisation or being somewhere in the middle. There can be other intentions as well. For instance, to bypass certain biases that the notation, the conventional Western notation already has. And I think there's a big ethnocentric, Westernocentric bias to think that the Western musical notation is some kind of rigid, exact, it's just order in its most complete form. That is just not true, because it comes with a lot of culturally conditioned biases of pitch and rhythm and the hierarchy of these. For instance, like it assumes that pitch is and rhythm are more important than dynamics, or that they're both more important than timbre, and that all of these are much more important than spatialization, and so on and so forth, for example.
Mm-hmm. That's true. Very good. And Andrew.
Yeah, I really like this discussion of cliches. I think I've already forgotten now what the quote was about maybe our instruments, we should aspire to our own instruments going on to have their own cliches. I think that's wonderful. I think we should take that away. I think there are definitely MRP cliches by now, and I guess and more generally, I think you can imagine describing a piece as sounding like a max patch or sounding like Nime or something like that. And I think, we've all experienced some performances like that, where, there are definitely cliches within an experimental electronic genre, as well as the sort of traditional ones. And I think maybe sometimes we spend a lot of time kind of shaking our fists at Richard Wagner and his his romantic contemporaries, and I wonder to what extent we gradually build cliches that we don't become aware of. I don't know. Because I don't identify anything cliched about any of the music that I think is at this panel. Maybe my own. I guess I could identify a really a kind of derivative Messiaen influence, but it's. I wonder at what point do you need to kind of break out of that feedback loop, in the sense that you kind of find the stable mode and it just kind of oscillates, and now you need to kick out of it and go find somewhere else.
Very interesting. Yes, Victor.
Regarding cliches, I definitely agree that any instrument or system will develop its own cliches, but I think cliches come out in improvisation when you forget the principle of listening more than you play, and you kind of just reach for whatever is most accessible and play that. So I was thinking what a lot of these instruments have in common is they insist that you listen to them because they're either extremely difficult to play something intentionally with the feedback instruments, or they're simply very entangled and unfamiliar, like Tabita's sculptures. So like that's possibly what's going on, is if the instrument insists that you listen to it to even, you know, get any traction, to make any headway, you're going to be less inclined to reach for a cliche, even if there is one to reach for.
And Guðmundur, Steinn?
Yeah, well, I would like to add, I mean, I sort of agree with what Victor was saying, but at the same time not. No, I have a different take on it. That why is cliche in and of itself necessarily undesirable? Because I think that like Marshall McLuhan, he wrote this I think a book or an article called "From Cliche to Archetype." You know, when you repeated something X amount of times, it's become a cliche. But if you repeat it much more times, it becomes kind of like an archetype. And like if you talk about endings in the Baroque period, or endings, like cadences in classical style, you're talking about thousands of pieces, thousands of movements, thousands of the same type of endings. And that's not a cliche. It's much more than a cliche. I mean, cliche is an understatement. And I think that in music, we rely a lot of that. And I think it's true that there are definitely cliches that we're not aware of because we're so deeply steeped in a certain aesthetic. And I think a lot of these instruments, they even feed into an aesthetic that has already started to take shape consciously or unconsciously. And I think that this is not necessarily a bad thing, but because I think that music doesn't necessarily happen on the most ground level. There'll be funky on top of funky on top of funky. That's just my opinion.
And Tabita?
I just wanted to think like what's the opposite of a cliche? So that would be novelty. And if you would imagine a piece which would constantly always show something new, that wouldn't make any sense as a listening experience maybe, or that would be quite overwhelming. And so I think we need some like repetition, let's say, and like I think evolving cliches or like archetypes helps us to take the listener and ourselves on a journey of experience. So maybe a notation or like a composition could be more focused on the communication between the player and the instrument, or the players together, or like the performer and the audience. So maybe it could be more about like the very basic thing of music, of communication, rather than frequencies, timbres, and because frequency and timbre and all that's what's like usually notated is the tool.
Brilliant.
To communicate something.
Yeah, brilliant. I think we've discussed notation quite a lot now, or areas around notation. But I'd like to maybe before we end the panel, focus a little bit on experience. You know, I think Adam mentioned it. I actually asked Adam a question after his talk about the experience of playing the instrument, and I'm curious for each one of you if you think that the instrument you're working with is different from playing other instruments, or what is the experience? For example, these are instruments that are quite distributed in its functionality. I mean, if you take the most basic instrument, let's say the recorder or some kind of flute, you have your hands holding an instrument and you're getting one sound out, but you're controlling it with many inputs, so many to one mapping, so to say. But what you have in these instruments here, you have so many outputs. We saw already in the score of Guðmundur for the halldorophone that there are 4 strings and 4 tracks there, so you might be splitting your brain into 4 channels, so to say, a bit like a drummer, you know, right hand, left foot, right foot, you know, that there are 4 things going on. And this is a different experience, and also then trying to understand the physics of the instrument, listening into the unpredictability and the agency of the instrument. I'm curious about, I've been throwing a lot of words here in the air, and I'm curious which ones you pick up on when you describe the experience of playing or composing for these feedback instruments. Does anyone want to jump in?
I can pick it up first if you want. I think the experience it depends in part on what you bring to it and what expectations you bring to it. I think first of all, with the Resonator piano, you forget quite quickly that there's anything digital or electronic about it. There is really quite a close coupling of hands to sound, and not just, and also you feel the vibrations of the instrument, especially in the low register. You feel it in the pedals, you feel it in your fingers. So it's quite immersive in a certain way. I think that when you first encounter it, maybe as a pianist or as a classically trained composer, maybe it's a bit familiar in certain ways, unfamiliar in others. But then I think what happens is you end up with these kind of microscopic spaces that are like, these little tiny doors that you can open that have these sort of beautiful worlds inside of them. And I think that's true of a lot of feedback instruments, actually. It's like, there's this whole space over here that sounds like this, and there's this whole space over here that sounds like that. But then if you can really manage to kind of hone in on this space right here, and you can be very careful, then you can kind of explore around. And there's just like all these kind of little miniature sculptures inside of it to explore. And that I think is a very different kind of experience.
Brilliant, yeah. Did I see another hand? Yeah, Adam.
Yes, something I'm increasingly finding with working with the feedback instrument is sort of also picking up from what Andrew was talking about, that it allows you to engage with things you had no idea could be going on in your instrument. At least with the bass I play with it. Sometimes I feel like I'm interacting with all the things that rattle on it that I had no idea would be loose if I had played it acoustically. Like it's like that kind of how the materiality of the instrument starts to kind of recirculate or fold back in on itself, creates these like kind of very interesting encounters with details, like material details of the instrument that you had no idea could have an impact on how sound is produced. It's, at least for me recently, that has been like an area of focus that I'm keen on exploring more.
Yeah, thank you. Yeah, Guðmundur, Steinn.
Yeah, I think the instruments, connecting to the topic, that instruments inspire you to compose from. When you're a composer, or you hear somebody play a certain instrument, maybe a certain musician, and that's like, wow, I want to incorporate some of this. And I think that also the experience of the very experience of playing. I think, for instance, 17th century, there would be sort of wealthy collectors of recorders that would just play them and collect them for the joy, the joy of drinking fine wine and the joy of playing a fine recorder made out of rare wood was like a thing that you do in your evening, and you take it up and the smell of it and the whole kind of so it's a very phenomenological sort of experience. And I think that's and with these instruments, it's actually really important to play them to understand what's going on, because it's a great experience to play. Like I only know the halldorophone, but I presume that any instrument that has to do with feedback has some kind of anticipation for the sound. There's some kind of there's this feeling of and the feeling of vibrations. And I think also very important is that the interface, or how you interact with the instrument, is attractive and simple enough to understand, and yet versatile. And on that note, I think that you know, the mixer could be exactly the same way. It's never the same. I presume, like, you're always going to find some surprises.
There's a surge, there's an anticipation, like you say, there is a prediction. You predict something is going to go some way or another. You're not sure, and then you have to respond to what actually happens and change your plan, maybe, if you have a plan. I don't know, Victor, what do you think?
I was going to say something that's just struck me about the mixer in particular is it has this incredible like sensitivity and sort of potential for nuanced control that I think comes from it being, you know, an instrument that's carefully engineered to do something, which is to mix audio. And kind of at the same time, every single sound it makes is by accident, and no one designed it to do that, which is just weird and maybe unique to the no input mixer, or to similar kind of misuses of complicated, precise systems for sound making.
Yeah, definitely. And Davíð?
Yeah, I just want to say this may be complete nonsense because I heard it somewhere, but apparently when you build fighter jets, which clearly are very related to this, they're built to be extremely unstable so that at any point they can fall out of the sky. And I find these instruments kind of interestingly on that line, which I think is kind of related to what Victor was saying. Just this act of like, you know, the mastery is stabilizing and knowing and reacting when you let it do what it wants to do, which may just be falling.
Sorry, I'm really curious now. Why do they design the fighter jets like that?
Oh, so they can like, basically if you're being chased or whatever, you want to get out of a missile's way, rather than have mechanical control to push you to do something, it's easier if you're always pushing, and then just like the natural thing is for it to just want to roll. Go. So if you're not actively flying it, it will crash at any given point.
Interesting. That's maybe something Guðmundur could add into the next score of the halldorophone, a missile. That,
high entropy movements.
Yeah.
Yeah, but I think, oh, sorry.
No, please.
Yeah, I think that it's still, because, you know, with electronic music and so on, you can define everything. So the appeal of these instruments has to also have to do a little bit with their instability, in a sense. But it's also the thing that if you have a plastic bowl that lasts forever, it costs $5. But if you have a ceramic bowl that's very delicate, it will cost $1 million, you know, or much more. So we are kind of attracted to delicate things, I think.
Right. I think we've been discussing a lot and really interesting ideas. I wonder if there are any comments or questions from the audience at this point. Are there any ideas that you're curious about, you want to ask further, or a question that you want a new, fresh perspective that you want to throw into the discussion? Feel free to put it in the chat. I haven't actually been following the chat because I've been on the panel so much, but are there any questions? You can also just unmute yourself and throw in a question if that's possible. I'm not sure who of you have that. Okay, doesn't seem to be much from the audience unless they're all trying to unmute themselves or are not able to. Panel members, is there anything you think you would want to raise at the end of the session? So I think we've had a really interesting day today, learning about these new instruments and the perspectives you brought in. This panel discussion was very interesting in terms of kind of thinking about the scope of the instrument, the role of composer, performer, the notation of the instruments, and the experience of playing it. And these are all kind of things that are so fluid, I think, in all of these instruments. You know, it's all moving. There is no there's no prescribed role of how a composer would compose a piece for a certain instrument, and how the performer is going to interpret it. It's all up in the air at the moment, and I think indeed that is the nature of digital musical instruments. I don't think it will stabilize at all. It could stabilize around certain instruments like the halldorophone or the magnetic resonator piano, but those instruments are probably going to develop further in the future and break out of that with new technologies or with new software for it and so on. So I think we're in a situation where everything is constantly changing, and that's something that some people find problematic, but others just embrace it and see the new music in that light. Which probably means that our technologies might get old and we might not have these instruments in 100 years' time. I think Halldór is trying to make sure that there will be haldorophones in 100 years' time, but and Guðmundur's pieces are going to be played, but who knows what's happening. That's also maybe the exception rather than what is typically happening. I think we're all moving. But that doesn't mean that the instruments that our knowledge is disappearing. I think the knowledge that we're generating now is just moving on into new instances of new technologies, you know. So we're building up knowledge sets rather than technological gadgets, i.e. instruments, you know. It's the knowledge that is important and goes forward. So in that light, I think this panel session has been super interesting, and it's so nice to have this kind of snapshot of what people are thinking at this moment in time with these new instruments. And yeah, I thank you all for a great session, and let's hope to see you all soon. Those of you who are here in Iceland, please come to our open labs at 3 p.m. on Fridays, where you can get in touch and talk further about these kind of ideas. And also, if you're interested in the magnetic resonator piano in particular, we're going to have further workshops on that instrument soon. And it would be great if you send us an email and just register your interest to be part of those kind of workshops. But yeah, if there's nothing else, I think we should just call it a day and start to focus on something else. Go out for a walk in the snow, maybe? Okay, thank you so much, and have a great day. Cheers. Bye-bye. Thank you.